Why do I need to learn this? It's a very common question asked in middle school and high school courses, especially in the subject of math. Students work with problems they can't visualize and recognize no need for these mathematical skills that they learn. One of the more notorious examples of why do I need to know this is a quadratic formula, and the truth is, you don't. Unless you're in a technical field, you will never need to use this formula in your life. An average student has seen this equation in one of their many algebra classes. Oftentimes, textbooks will provide word problems that relate to odd real-life scenarios, such as some weird problem optimizing price. Yet these problems give the illusion that they are useful. No student needs to solve this problem, especially not by using a quadratic formula. Even for problems that do have real-world applications, like this physics-related problem, many students don't plan to enter fields where they need this content. I remember once my pre-algebra teacher told me that these formulas were used in making bridges, which somehow provides enough reason that we should be learning it. This illusion gives students the thought that math is only useful in these contrived situations, where each additional $2 increase in price directly results in 5 less gym members, or in these situations where you are a bridge builder, which I wouldn't think the majority of students have dreams of becoming. Not that there is anything wrong with civil engineering, but middle school students have a wide range of aspirations. So, now that I've explained why I think math isn't useful, I'd like to explain why I think it is. For students to be mathematically capable, they must develop skills which not only help them solve problems, but understand them. These skills are conceptual understanding and procedural fluency. Conceptual understanding, defined in the book Adding It Up, is an integrated and functional grasp of mathematical ideas. Students with conceptual understanding know more than just isolated facts and methods, while procedural fluency, according to the National Council of Teachers of Mathematics, is the ability to apply procedures accurately, effectively, and flexibly, to transfer procedures to different problems and contexts, to build or modify procedures from other procedures, and to recognize when one strategy or procedure is more appropriate to apply than another. In a very simple example of these two methods, let us look at fraction addition. Take 1/3 and add it to 1/6. Students are told to multiply the numerator and denominator by 2, then add the new fractions we get. Being able to apply this set of steps, or rather, procedure, can be called procedural fluency, and students must be able to apply it accurately and to apply it to other fraction addition problems. Conceptual understanding would be the ability to recognize what these numbers represent and why they add to 1/2. And most students have a conceptual understanding of this problem since it is very easy to visualize. To the wide majority of students, math is taught for these skills, not particularly the skills of factoring, graphing polynomials, or computing the vertex, but for its ability to teach critical thinking, skills that develop with the idea of procedural fluency and conceptual understanding. Math at its most basic form is problem solving. It's being able to understand logical sequences and apply them. Throughout life, you will always be required to use these skills. Just as athletes exercise and train their muscles, math has a purpose of training your brain.